One final example of being able to work with, or a couple final examples, excuse me, of trying to work with these integrals is we have an integral of 5x for 5/8 root of x dx. And so just like the previous examples, we can write this as 5 on the outside of the integral. And then we're going to rewrite this as x to the 1/8 power. Now we can go through and we can just use the rule for antiderivatives. So this is going to be 5x to the 1/8 plus 1 divided by 1/8 plus 1 plus c. And then we can just go ahead and evaluate this. So if you want to just go ahead and check in your calculator just to make sure I'm not lying to you, 1/8 plus 1 is 9/8. And now we can just multiply by the reciprocal of the denominator, just like we did in the previous video. So it's going to be 5 times 8 over 9, x to the 9/8 plus c. And then finally, we could just simplify this out. 5 times 8 is 40 over 9. And then we have the 8th root of x to the 9th plus c. And of course, we want to check this by differentiating. And so if we call this capital F, so let's just call this guy capital F, and just rewrite this as 49th x to the 9/8 plus c, then F prime would be equal to 49th times 9/8 x to the 9/8 minus 1 plus 0. In the numerator, that just becomes 360. In the denominator, that's 72. So 72 over 360 is going to work out to be 5. All right. And if you don't believe me, just use your calculator, or you could just say the 9's cancel and 40 over 8 is 5. We get x to the 1/8, which can be written as 5/8 roots of x. And that's exactly what we were looking for. Because if we go all the way back, we have 5/8 roots of x. This is a type of problem that does indeed, a lot of students just get this wrong because they think they know how to do it correctly, but unfortunately they do it incorrectly. So one of the things that I see students doing is they do this. They take integral of 8x plus 3 dx, and then they multiply it by the integral of 1 minus x dx. And unfortunately, that's completely incorrect. Right? We can't just go through and factor off an integral and create two integral signs out of that. All right, so what is the correct way? Well, the correct way is to go through and do some algebra on this animal first. All right, so let's do that. Let's just go ahead and FOIL it. And I'm going to rewrite this as just FOILing 8x minus 8x squared plus 3 minus 3x dx. Okay, or another way we could write this is just 5x minus 8x squared plus 3 dx. Okay. Or if we wanted to separate this into now 3 integrals, we could write this as 5 integral x dx minus 8 integral x squared dx plus 3 integral dx. And now we could just integrate each of those one by one by using our regular integral rules. So we're just going to add 1, divide by the new exponent. So this is going to be 5x squared over 2. All right, so remember that has an implicit 1 up there. So we just add 1, divide by 2, minus 8x cubed over 3 plus 3x. All right, so think of this as just a 1 in here, 1 dx plus c. And then finally, if we chose to, we could write this as 5/2 x squared minus 8/3 x cubed plus 3x plus c. Okay. And so if we wanted to check this, we would just find the derivative, all right? And we might have to factor it. So if we go through and find the derivative, so let's call this f of x capital. So f prime of x is going to be equal to 5x minus 8x squared plus 3. And if we wanted to factor it, what we could do is we could factor and just rewrite this as negative 8x squared plus 5x plus 3. And this would factor into, we could do 8x if we wanted to at the beginning. So in fact, that's the way it is up here. So we could just kind of cheat and we could just say 8x plus 3, 1 minus x. All right. And of course, we would check that, all right, and we can check it, and it does actually equal to this negative 8x squared plus 5x plus 3. And the good news is that that was the original integral. All right, so just one last little note about integral before we conclude with this video is just giving some names to some of the things that we've seen so far. All right, so let me backspace, get some room down here. No, that's fine. All right. And so this is going to set us up nicely for the next series of videos. So whenever we have an integral, this thing is called the integral. Whatever's inside the integral is called the integrand. All right. So for instance, the integrand in the first problem that we just, or the problem that we just looked at, is going to be this 8x plus 3 times 1 minus x. Okay, so that's our integrand. Right? A couple other things to keep in mind is that in the next series of videos, we're going to start seeing the difference between a definite and an indefinite. So an indefinite integral looks something like this, the integral of 3x squared dx. A definite integral looks something like this, the integral with a lower bound of 0 and an upper bound of 1 of 3x squared dx. All right, so the only difference between an indefinite and definite integral is that you have these things called limits of integration. All right, so those limits of integration are going to be on the definite integral. All right. One other thing is that a definite integral does not get a plus c in the answer when we evaluate. An indefinite integral does get a plus c at the end. All right. We're going to see this in the next series of videos, but just setting you up for those so that way, if I start to use these types of terms, that you do understand them.